What's up everyone, Patrick here, welcome back. Moving on to the next example, we have to solve each of these systems here by elimination. So starting with number one, we got 3x minus 4y is equal to 2, and then 6x minus 8y minus 4 is equal to 0. Okay, so finding the point of intersection between these two lines. Now, when I'm doing elimination, I first like to make sure that everything is lined up, and personally, the format that I like is having everything in this format, where we have the x, the y on the left side, and then the number on the right side. But you can have it in a format where everything is on one side like this. Personally, I like this format. So what I'm going to first do is I'm going to take this and put in this format, so we just have to bring the -4 over. So I'm going to rewrite that first line. And then right on top of it, I'm going to write this line, but just line up those formats like that. And so what do we do with elimination? We want to get rid of the x's or the y's. So we want to multiply either one of them or both of them in a way where the x's, the coefficients, let's get rid of the x's in this case, where the coefficients are going to be the same, or the absolute value of them are going to be the same. You could have a plus and minus, then you would add them to get rid of it. But in this case, notice that we have a 3 and a 6, so really easy to just take this line and then multiply it by 2. So if we do that, we'd end up with 6x. You have to multiply everything by 2. -4 times 2 is -8. 2 times 2 is 4. And notice that what happens, we actually end up with the same line. So whenever that happens, there's an infinite amount of solutions, because notice that if we subtract this from this, right, 6x minus 6x would give us 0x as expected. But now notice the y's are also going to cancel out. -8y minus -8y is like -8y plus 8y. Which would give us 0y. And then 4 minus 4 is 0. So these end up being 0. Whenever you end up with 0 equaling 0, it means there's an infinite amount of solutions. And what that graphically means is that they're basically the same line. Right? They're stacked on top of each other. It's the same line, so they're going to have an infinite amount of points of intersection, right? So if you ever get to this in your steps doing elimination, then there's infinite solutions. Now, what about number 2? Same thing. Notice that here, this first one's already in the format that we like, x minus 3y is equal to 1. But this one isn't, so what I'm going to do, we can bring the 3 over. What I'm going to do is I'm actually going to bring the 9y over and then the 5 over. So we're going to rewrite this line here as 3x minus 9y is equal to -5. Okay, and if we interchange both, we can just write it as 3x minus 9y is equal to -5, like that. So putting these on top of each other, x minus 3y is equal to 1. And then we got 3x minus 9y is equal to -5. So in this case, let's get rid of the x value. So it's easy to just take this one, multiply it by 3 to make it the same. So if we take this, multiply it by 3, 3 times x is 3x, -3y times 3 is -9y, and then 1 times 3 is +3. And what happens when we subtract these, 3x minus 3x is 0. X makes sense. We're getting rid of the x's. But notice again, the y's are going to cancel out too. -9y minus -9y is -9y plus 9y, which gives us 0y. Then -5 minus 3 gives us -8. And so in this case, we actually end up with 0 equaling -8, which does not make sense. That can't happen. And when you get something like that, whenever you get 0 equaling a number, it means that there's no solution to this. All right, so just wanted to go over an example like this that you may run into either this scenario, 0 equaling 0, which is infinite, or 0 equaling a number, meaning that there's no solution. And graphically, what this means is that both lines are parallel, but they have a different b value. They're different lines, but they're parallel, so they're never going to intersect. And then you can actually see that, just to take it a little step further, if we convert these to y equals mx plus b form, so this one over here, I'm going to bring the 1 over, I'll bring the 3y over, negative 3y over, so it becomes positive 3y, divide everything by 3. Actually, before doing that, let's just switch the sides, divide everything by 3. And this line is y equals 1 over 3x minus 1 over 3. Okay, so that's this line. If we do the same thing here, notice the y is already isolated, so let's just divide everything by 9. Y would be 3 over 9 is 1 over 3, x plus 5 over 9. So notice, same slope, meaning that the lines are parallel, but a different b value. Okay, so it's not the same line. They're parallel, but they're apart from each other. They're never going to intersect, hence there is no solution.